Okay, so last lesson we learned about finite sums that end, but today we're going to be learning about infinite sums that never end.
Yes, Professor.
So, what if you do one? Oh, actually, let's start. Start with 1/2 plus 1/4 plus 1/8 plus 1/16. And it keeps going forever and ever. We would write this like, this is not too important now, but it might be important later. We would write this like this. That just means when n is 1, this is a half, n is 2, this is a quarter. You just halve it each time. And then you add it all up. Now, if this goes on forever, wouldn't the answer be infinity? Well, let's try this out. Let's say you have a square, and the whole square, let's call that 1. The amount of area it has, the surface area, is 1. It's not surface area. So, this would be 1/2. 1/4 is just a half of what's left. And now we have 1/4 left. So now it's 3/4 shaded. And now 1/8 is once again a half of what's left. Do you see the pattern here? Every number we add is just 1/2 of what's left. So until forever, it will take forever to even get to 1. So a
Never
half.
finish it.
So we say that 1/2 plus 1/4 plus 1/8 going on forever is 1.
Though it will be less than 1 really at all times.
Yeah.
Yeah.
And any finite number of terms, whenever you're adding these up, like actually you will never get to 1. You'll have to do that forever, which you can't. So the thing is, this sum, infinite sums, they don't actually exist in their full form. You cannot, but they do get closer and closer to something. So we say that when we do it forever, it is that thing.
Yeah.
But now, I want to find a way on how we can actually figure out what it is without using diagrams. This is like pretty kind of, this is the most basic example. But like, what if you wanted to do something a bit different? Like, what if you change this 2 to a 3?
Ooh.
Now, it'll be 1/3 plus 1/9, 3 times 3, plus 1/27, 3 times 3 times 3, plus 1/81, 3 times 3 times 3 times 3. How will you figure this out? Actually, this is not 1, we don't know yet. How will you figure what this is? Well, we can do a clever trick. Let's multiply the whole thing by 3. This will become 1. This will become 1/3. This will become 1/9. This will become 1/27. Because when you multiply a third by a third, you get 1. 1/9 by a third is 1/3. And look what we have here. It's the same thing that we started with.
Yeah.
So multiplying it by 3, we've just added 1.
1.
So 3 times whatever this thing is just the same thing as plus 1. I'm struggling a bit for space here because I have a bit too many signatures. So if 3 times it is it plus 1, then 1
Is
is just 2 times what it is, which means
yeah.
it's a half.
Yeah.
We can use this trick for even something like,
Ah, that's clever actually, Isaiah.
Very clever.
That is tricky.
I could also understand this.
we can use this trick. Nani understanding that?
Yes.
We can use this trick for something. You can even do it for 5. You can do it for any of this type of number. 1/5 plus 1/25 plus 1/125th, 1/625th, and we're trying to figure it out.
So
Now
you
if we
multiply
the whole thing by, guess what?
5.
Yes, multiply everything by 5, so now this becomes 1/5, 1/25th, 1/25. So now look, we have the same thing as we started with,
Yeah.
just plus 1.
Exactly.
5. So 5 times this is this thing plus 1.
Rush to AB.
This.
So 5 times the thing is this thing plus 1,
Yeah.
which means
This thing is.
4 times it
Yeah.
is 1.
So it's one.
So it is
fourth.
1/4.
Hmm.
And this will be true for all of them. Whatever this number is, if we sum all of these things up like this will be 1 less than that.
Hmm. Clever.
And if we change the top up here to whatever this is,
This will just change.
to this.
Hmm.
So if this is like 2, this will be 2/4. This is 3, this will be 3/4.
I see.
Because everything's just...
That was clever.
Wow.
Thanks for listening!
Thank you, sir.